Okay, so now we're going to find indefinite integrals just using the rules now. So we've learned all the rules that we're going to learn thus far. So like I said, we'll do some more U sub later in the course, and then that will complete it for AP Calc AB. But for right now, we're just going to get some practice with the rules that I've taught you guys, right? So we know that this is going to be the indefinite integral of the first function plus the indefinite integral of the second function, because that's the properties of integration that we've had. And again, very similar to properties of derivatives, like finding derivatives. Okay, and then the other thing that I wanted to point out is this 3 over x looks kind of weird, just because what we would typically do is rewrite this as 3x to the negative 1, right, to bring it to the top. However, we know the rule for the indefinite integral of 1 over x, so it might be helpful if I just write it as 3 times 1 over x, just so you can see where I'm going with this. So again, just gonna kind of rewrite this plus integral 3 times 1 over x dx, so that you can see that I'm leaning towards this being ln of x. Okay, so what I'm going to do now is I'm going to copy this 4, right, because I have a constant times a function, so I'm going to copy the 4 times, now the antiderivative of e to the 2x is e to the 2x divided by 2, because of this constant here. Okay, and then plus 3 ln absolute value of x plus c, because again I copy the 3 times the antiderivative of 1 over x, which is ln absolute value of x plus c. And I guess to simplify that further, if I think of this as 4 over 1, then this would be 2 e to the 2x plus 3 ln absolute value of x plus c. Okay. So now looking at part B, again I can split this up here, but just looking at this first part, how do I find the antiderivative of sine again? Well, again, repeating this pattern here, I go down to where sine is so that I can go up 1 and see that it's negative cosine. So I'm going to copy the 2 and then times the antiderivative of sine, which is negative cosine of x. Okay, plus the antiderivative of cosine, which is sine. So this is going to be sine of pi over 2 times x. But then I have a constant times x, so I need to divide by pi over 2. And then plus, what's the antiderivative of a constant? Well, it's the constant times x plus c. Okay, and then just to get this to kind of look a little bit more like probably how College Board would have it, this would be negative 2 cosine of x plus 2 over pi sine of pi over 2x plus e times x plus c. Okay, so remember that e is a number just like pi is a number, and like we had, just to kind of recap some old, not old antiderivative rules, but ones that we came up today in class, we basically said that this was x to the n plus 1 over n plus 1 plus c, and then the other one we had was the antiderivative constant, so it's a constant times the k plus c. So those are the other rules other than the specific rules gone up here that we have. Okay. So we'll get more practice with that in class. But the last thing I want to kind of just introduce to you right now, and we will do more of this on another day, but this is the most important theorem, I should say, in calculus. It's called the fundamental theorem of calculus, hence its name, the fundamental theorem. Okay, and what it says is that if the function is continuous from a to b, then we say that the definite integral, so the integral from a to b, of f prime of x dx is equal to its antiderivative, which would be the original function, f, evaluated at b, minus the function evaluated at a. Okay. So what's the purpose or the use of the fundamental theorem of calculus? Well, it helps us solve a lot of different problems, right? But for right now, it's most useful for the fact that it can help us find definite integrals without a graph or a calculator, right? Because before we would look at the graph and find the area between the curve and the x-axis to find the definite integral, or we would just put it into the TI-84 and hit Math 9, and it would tell us the answer, right? So now we can do this by hand. Now here's the thing, that we can use any antiderivative to find the definite integral, okay? Because as we know, we can have a whole family of antiderivatives. So we can use any one we want, and it will still get us the exact same answer. However, a lot of times what we do is use the antiderivative where the constant is 0, okay? So you're going to see me find an antiderivative by not adding the additional plus c at the end. But that's because I'm solving or finding the definite integrals. Okay, so again, the indefinite integral represents all the antiderivatives for that function, so the family of functions, whereas this is just going to be giving me one answer, right? Okay, so looking at this question, I want to find the definite integral from 1 to e of this function right here, 3 over x plus 2. So what I'm going to do is find an antiderivative. So I'm just going to actually, before I do that, just kind of like we did previously, just so you can see that this is 3 times 1 over x plus 2 dx. Okay, so now when I go to find an antiderivative for this, this would be copy the 3 times ln absolute value of x plus the antiderivative of 2 is 2x. Okay. And again, this is just one antiderivative, so I'm going to just not bother adding plus c, and instead in my mind I'm adding plus 0. Okay, I'm just picking when the constant's 0. And so now I'm just going to plug in my bounds. So what is my b value? It's the e, right? And my a value is the 1. So I'm just going to plug in e. So this is going to be 3 ln absolute value of e plus 2e. And this whole thing is going to be subtracted by 3 ln absolute value of 1 plus 2 times 1. Okay. Now simplifying this, ln of e is 1. So this is going to be 3 times 1 plus 2e minus, and then ln of 1 is 0. So this is 3 times 0 plus 2. So I'm getting 3 plus 2e minus 2, which is the same thing as 1 plus 2e. Okay, let's try another example. So again, gonna find, this is my function here, gonna find the antiderivative, or I should say not the antiderivative, but find an antiderivative and plug in the bounds. So I gotta remember Santa Claus here. This gets confusing for me. So I have negative sign, so I know that it's gonna be cosine. So this is gonna be cosine of 2x. But then I have a constant times x inside, so I gotta divide by 2. And then plus x squared over 2. And sorry, x squared over 2, and then my bounds are from 0 to pi. Okay, and just to recap that, that's because the power is 1, like x to the first is the same as x. So I'm adding 1 to the power and dividing by that same power. So going back to this rule right here. that we did today in class, right? Okay. And so now I'm going to plug in pi and for x. So this is going to be cosine of 2 pi over 2 plus pi squared over 2. And I want to do this whole thing minus, now I'm plugging in 0. So I'm going to have cosine of 2 times 0 over 2 plus 0 squared over 2. And so simplifying this, cosine of 2 pi would be 1, right? If I draw out the circle, 0 and 2 pi are at the same spot. This coordinate here, and that coordinate is 1, 0. Cosine's the x-coordinate. So this would be 1/2 plus pi squared over 2. And then cosine of 0 is 1, so minus 1/2 plus 0. So I get 1/2 plus pi squared over 2 minus 1/2. So these 1/2s cancel, so I just get pi squared over 2. And there you have it. So that's the fundamental theorem of calculus, right? Just going back, that basically it says if you have a definite integral from a to b of a function, you can find its antiderivative, I should say, and plug in the bounds, basically, and subtract them. So that's basically all we're doing here.